My name is Daryl Spitzer, and I work for Altera's Santa Cruz Technology Center. I'm going to
need to face the mic.
Here. And I'm going to do a demo. And that's why I need my machine here. I need to connect to my desktop machine back in Santa Cruz. So hopefully I have my passwords all typed in here so I can just connect. And it should hopefully automatically bring up the connection to my PC. Here it comes. And hopefully it scales the right screen size. I guess we'll find out. While I'm waiting for that to come up, while I'm burning my valuable 300 seconds here, I think I will take a picture of what it looks like from up here. Put it on my blog. Say cheese shop.
Your slides up.
Okay, I'm ready. It doesn't look like it scaled perfectly, but it looks like I can scroll around here. Okay, so this is an idea of, this gives you an idea. This is from Altera's website, so it gives you an idea of what our products are. We make FPGAs, programmable chips, and what my group does is we make tools that allow you to build embedded systems onto our programmable chips. So Cordis is made by another part of Altera, but we make SOPC Builder, which allows you to stitch together a whole bunch of IP, and the Neos 2 IDE and Neos 2 EDS, which is a CPU and a tool chain to allow you to build embedded systems. So what this means is we have a heck of a lot of tests to run, and so we've built this system called the Altera Compute Environment, which allows us to run all these various tests in different suites and keep track of them. So you can see all these little bars up here are all the different builds we have, and they give you an idea of how much is passing. And we do hourly and nightly builds, and the hourlies will pass, lately actually probably 2 out of 3 times. The nightly builds are never all green, and you'll see why. So here's a recent nightly build, and if I scroll down, is it going to let me scroll down? Come on. Okay. Whoop, too far. Getting close. Okay, so in that particular nightly build, we ran over 9,000 tests, and for us, that's not too bad. We had about 3% fail, but you know, out of 9,000 tests, we can never get them all green. So how do we manage all these failing tests? One thing we do is that we tag all our tests, or we independently have tags based on regular expressions, so that we look for certain patterns in the output of these tests, certain failures. And so what you see here on the right-hand side is a tag cloud, and this isn't an ideal example because we've got a whole bunch of individual failures and one failure that happened a lot, but at least you get an idea that, you know, this one happened many times. Then we have a list of all the tags down here, and using our bug tracking system, we can assign bug tags to them. I better keep things moving quickly here. Scroll back up. Another report that we found useful, especially for the hourly tests, is to have a history of each hourly test, and so we can see which tests have failed and which ones don't. And very quickly we can see where there's intermittent problems or where there's a recurring problem. Got a couple minutes left yet. Maybe a little trouble scrolling with the trackpad. Maybe I can use the keyboard. So I guess the point I'd want to make in conclusion is, since I better, is that I don't profess to be an expert on running thousands of tests. We've kind of come up with, kind of grabbed the low-hanging fruit as far as getting these thousands of tests under control, but I'd love to hear from any of you if you have any ideas on systems that are out there, or ideas on changes we could make to our system to go after all these red squares. Thanks.